We're going to use the exponential growth model A equals A0 times e to the kt, in which t is the number of years after 2000, to find an exponential growth function that models the data described above. The general exponential growth model, the A stands for the amount after time t, the A0 would be some type of initial amount, the k would be the exponential growth rate, and then the t is, in this case, the number of years. It's the amount of time. So we have two pieces of information given to us that in the year 2000 the population was 807 million. Since t is the number of years after 2000, in the year 2000 is our initial amount. So this A0 is going to be 807. We can find that out even just by plugging in the rest of what that same piece of information tells us, and that is in the year 2000 t would be equal to 0 because it's 0 years after 2000, and I could use that 807 million as my A, my amount in that year 2000. If I plug those two things in, I will see that I'll be able to solve for A0. So I would have 807 equals A0 times e to the k times 0. Well, k times 0 is just 0. So I have 807 equals A0 times e to the 0. E to the 0 is equal to 1 by definition. So we have 807 equals A0. So essentially our initial amount for this entire problem is that 807 million. So my exponential growth model at this point can be written as A equals 807 times e to the kt. Now in the end, in order to answer this question, we're looking for that exponential growth function. So I want that t to remain variable. It's the number of years after 2000. That means that all that's left is for me to figure out this value of k. In order to do that, we're going to use the second piece of information that's given. And that is in the year 2000, population is 1,052 million in the year 2011. In the year 2011, t is equal to 11, since that's 11 years after 2000. And again, we see that they're giving us the value of a is 1,052. So plugging those numbers into our current exponential growth function shows us that we have 1,052, that's our a, equals 807 times e to the k times 11, or 11k. Now to start getting k by itself, we're going to divide both sides by 807. So we get e to the 11k equals 1,052 over 807. And then we're going to rewrite this equation in its equivalent logarithmic form. So that logarithm is going to have a base e, we call that a natural log of 1,052 over 807, and that's going to equal 11k. So we're just going to divide both sides by 11 to get k by itself. So we have k equals natural log of 1,052 over 807 divided by 11. So we'll go ahead and punch that in our calculator here to get a decimal approximation. That comes out to 0.0241 and so on. We'll go ahead and round it there to 4 decimal places. So now using that value of a, I can complete my exponential growth function, which should look like a equals 807 times e to the 0.0241t.